Okay, guys, we're moving into Unit 10, Lesson 4. We're going to talk about some histograms, and really a histogram is bar graphs, and it has intervals across the bottom or the x-axis. So this is still x, and this is still y, and we have a bunch of questions that we can answer from this, and they're really neat because we can take a dot plot and construct a histogram, and they're really nice to take a look at. So let's get into this thing, and let's get after it today. Histograms show data in intervals. Right, or ranges. They are similar to bar graphs, but each bar touches the other. And they are similar to dot plots because they represent the overall spread and shape of the data. Okay, an example of this could be, if we think about this, could be decades. Or another example would be, people's age ranges. Those would be examples of good use of a histogram. Okay. All right. So let's take a look at the National ACT exam scores. Okay. And I'm not sure what the ACT exam is, but I think that matters really. So let's go. All right. So we're going to use this histogram to answer these questions. How many scores were included in the data set? How many scores? So what we would do is not count these numbers. We would count these intervals. So we would count this as like, 16. This is like what, 34, plus this is about 27. This is about what here, about 17. And this looks to be about 3. So when we add all of those up, it's going to be approximately 100. The interval's 5, so we can't be really precise. So I'm just going to put 100 down when I added all of those up. How many are from 1 to 5? Well, it looks to be about 1. There's just a little bit of a bar there, and a little bit that continues over for 6 through 10. Now, if we go up to 11, all right, here it is, 15. There's 20. I'm going to say that's about 16, okay? Some would say 17, but I'll put 16 down. Again, you're not going to lose points for being 1 off there. 16 through 20 goes clear up and almost touches 35, so we'll call that 34. 21 through 25, I'm going to call that about 28, all right? Some might call that 27. I don't think it's 29. 26 through 30, here's 15. It's a little bit above is 16. And then the last one, we'll just estimate that to be 3. So those, if you add all of those up, should give you the number of 100 or very close to it. And that's the idea of it, okay? Which range of scores represents 17% of the data? Okay. Well, when I look at this, if I have 100 overall, and all percents are out of 100. So if I think of it that way, I'm looking for something that's 17%. Well, when I look at this, I have really 2 options, so I better go back and evaluate this because it's out of 100. So 11 through 15, we could call that maybe 17. And 21 through 25, I'm sorry, 26 through 30, that's more to 16. So you know what? I'm going to go back and change this. That's a little bit higher than that one. I'm going to call that 17. So it's 17 out of 100, which is 17%. So it would be the ACT scores, right, of 11 through 15. So we just adjusted a little bit, right? What percent of the scores are included in 21 to 25? All right, well, we know it's out of 100. There's 100 total responses there. 21 to 25, we look at this data, is 28 out of 100, which is about 28%. Not about, it is, right? So you're getting the idea. They made it nice for us because they made it out of 100 total responses. What 2 ACT score ranges make up more than 60% of the sample? More than 60%. Okay, so when we look at this, we're looking to add those. When we add them together, what two ranges make up more? That's the key, more than. So when I look at this, I'm going to see here, 60% of the data. So when I look at these two, clearly if I take these two and add them together, so 16 to 20, right, is 34, and 21, that's 28. And when we add those two together, we should get something greater than that. So if we add 28 to that, get 12, That's 62%. So it's about 62%. So the scores of 16 through 20 and 21 through 25. Okay? And that's what we're looking for. How does the number of scores between 11 through 15, okay, compare to the number scores or to the number of scores between 26 through 30? Well, 11 through 15 is 17, okay, and 26 through 30 is 16. So if I compared the two, all right, they're very close. All right, there's just one more. So there's just one more, right? One more score in the 11 through 17 range, right? Okay. So let's finish up here on the bottom, and I think there is a second page. I'm not sure. This was quite a bit for the first page. That's good. Write 3 statements about the graph below, 2 that are true, 1 that is false. Okay. Well, let's start with the true ones. So we got 2 there, right? And so when I look at this, the numbers, the numbers 1 to 5, and I see, let's see here, 26 through 30, 1 to 5. When I take these two, all right, and add these two together, it's the same as this. So 1 through 5 and 26 through 30 equals 11 through 15, if that makes sense. So that is a true statement. These two added together equals that. The next one, if I look at, I don't know, let's take a look at 16 through 20 and 21 through 16 through 20 and 11 through 15. So how would I look at this? 16 through 20 is 34 and 11 through 15 is, so look at that. So 16 through 20 is double the scores of 11 through 15. So, and the answers are going to vary here. You can come up with whatever you want, right? When I see that. What's a false statement? I don't know, 1 through 5 is the greatest because it's not. It's the smallest bar. Okay? All right, let's flip the page and keep going. Got a couple more problems to answer here. All right, this is a pretty good lesson, so let's go. I'm going to use these two to answer these questions pretty much. It says the local library surveys patrons. It's based on their age. Let me check it. We're in good shape. All right. Use the histogram below to answer questions 6 through 9. Determine the total number of library patrons surveyed. So we would just add them up. So one way to do this is we could call this 8. We could call this 15. We can call that about 6. This would be about 2. This would be about, let's call that 7. And this one probably goes up to, here's 10. We'll call that 12. And when we add all of those together, we're going to get 50 patrons. All right. How many library patrons are younger than 30? Younger than 30. So now that I've written these, I'm just going to add those two together, right? That makes it easy. 15 plus 8 is 23 patrons. Okay. Based on the information in the graph, which 2 age ranges are responsible for exactly 40% of the patrons? Okay. So here's what I would tell you. If we have a total of 50, and I double that and I multiply that by 2, it's 100, right? So now I'm in percent mode because it's out of 100. So if I double the bottom, I'm going to double the top number. So I need something, all right, that's really going to equal 20 because when I double, it's going to be 40, right? So, let's see what we can come up with here, all right? 40% of the patrons here. So it's going to approximately be, maybe we're going to have to add here. I don't know. Let's see here. 8 and 12. Let's see if we add these two together, we're going to get 20, and 20 times 2 is 40, and there's your 40%. So what did I do? I have 10 through 19, and I add that to 60 through 69, and those are the two ages, right? Added together gives us 40%. Based on the information in the graph, in which age range are 30% of the library patrons? Which age range? All right, well, 30%. So again, if it's out of 50, and I look at this one, and I'm just going to start with this one. This 30 through 39. That's 6 out of 30, and we're looking for that. So that's what? Is that going to be big enough there? 20 through 29? No, because when I double it, look, I only get 12%. That's not what we need. 30%, right? So let's try this again. So if we start with 50, and let's try here, 20 through 29, it's 15. All right, and when we double that, it's 100, and we double that, it's what? 30. So there it is, 20 through 29 is what we're looking for. So just scaling it up helps us. Let's take a look at this other side, and let me check our deal going on over here. A group of runners chart their distance total for the week. Use the histogram below to answer the questions. So again, more information. Again, the histogram, the bars are side by side, they touch. We have intervals going across the bottom. We have decimals now, so we got some good stuff going on here. All right, so let's take a look at this. How many runners run between 3 and 4 9/10 miles each week? 3 and 4 9/10. So again, you know what I'm going to do? I'm going to write these values above it because that helps me. All right, and this is 10, that's 5, and that's 5. So now I just 3, and I'm going to get 20 runners, right? Because 8 and 12 is 20. How many runners run less than 4 miles each week? Less than 18, and 10 is 28. That's what I see. 28 runners. All right. Which of the following statements best represents the data above? Okay. So let's go down through this. 25% of the runners surveyed run 4 to 4.9. 25%. Well, if there's a total of how many here? 12, 20, 30, 40. There's a total of 40 runners, right? And you're telling me that 4 to 4.9, right, is 12. So what we can do here is just check that with our calculator. Sorry about that. And if we take that, all right, and turn our calculator on, let me clear it. If I put 12 over 40, and then, I change that to a percent, what is it equal as a percent? That's 30%. So no, that's false. Doesn't work. 1/3 of the runners are 2 to 2.9. Okay, well, we have 40 out of 30. No, because that reduces to 1/4, not 1/3. So that's wrong. 1/5 of the runners, 3 to 3.9. All right, well, let's check it. 40 total runners, 3 to 3.9 is 8/40ths. And we want to see if that goes to 1/5. Well, does it? 8 divided by 8 is 1. 40 divided by 8 is 5. There it is. So it's letter C. So there's some good math in here. We're building up, and hopefully that processed in your brain. Have a good day, guys.